Guys, it's Miss Landry again, and for this video we're going to learn a little bit more about the experiment and then move on to becoming a critical reader of science. So let's start where we kind of left off. So if you remember, we were talking about our little group with our Cheeto experiment and whether or not it increases hip circumference. So when you set up an experiment, you need to put your volunteers into different groups. Okay, and there's two different groups you need to know about. The first one is called an experimental group. So this is the group that will be exposed to the actual thing you're changing. So like if I'm doing a drug experiment, this is the group that will get the drug. Or if I'm doing the Cheeto experiment, this is the group that will get the Cheetos, okay? So the experimental group is the one getting the experimental variable. The control group, on the other hand, is used to compare the results, and they are not getting the experimental variables. So in the Cheeto example, if you remember, we had a group that got no Cheetos, a group that got 25, and then a group that got 100. So the control group would be the group that got 0. In a drug experiment or a clinical trial, generally we do something called a double-blind experiment. Okay, so this is when the group that's not getting the drug still gets something, and it looks exactly like the variable or the drug that is being tested. So in a double blind, both the person getting it and the person giving it, so the experimenter, doesn't know who's getting what, because this avoids bias, right? So double blind experiments are probably the most powerful type of experiment that you can do, in which case nobody knows what they're getting. They could be getting the experimental drug, they could be getting a placebo, which looks like the experimental drug, but it's not. And then that way we can control the results of those that did get it to those that did not. Hope that makes sense. So let's look at how we can set it up. So let's say I'm doing an experiment on my Cheeto, right? So you can have either a random assignment of people or a random sample of people. So let's talk about what the difference of that is. In a random sample, I'm going to choose just random groups of people. So if I'm like at Kent, I'm just going to choose like every third or fifth person that walks through the door. Or maybe I have like, some of your teachers have probably used like the name generator, like it spins the wheel and it picks random people at a time. So it could be something like that. Or you pull something out of a hat, a number out of a hat. That's a random sample. A random assignment is when you randomly assign them to the different groups. So let's say I have, 300 people in my Cheeto experiment. So 100 are going to go in the 0 Cheeto group, 100 are going to go in the 25 Cheeto group, and then 100 are going to go in the 100 Cheeto group. I will assign them randomly, meaning I have no idea which group they're going to go into to start. So I'm going to just randomly assign them, which gives your experiment a little bit more power. One thing that's really important is something called a confounding variable. Think about the word confound. If I say, oh, that confounds me, what does that make you think of? It's kind of confusing, right? And that's exactly what this variable is. It's basically another variable that you might not have thought of that could influence the outcome of the experiment. So I want you to think about my hip circumference and Cheeto example. What are some confounding variables that I need to be aware of? Pause the video and answer that question. Okay, so there's a lot, right? So it's what else they eat, how much exercise they get, genetics, metabolism. This is why human studies are so difficult. The genetics in humans is really a confounding variable. And how do you control for genetics? Well, one way is twin studies, but we'll talk about that down the road. What if we look at the one about the rats, right? So sleep deprivation causes the rats to lose their will to live, when in actuality, it's actually causing muscle atrophy. Atrophy meaning like they don't work as well. And so the muscles that the rats are using to swim are actually really tired, and therefore they can't swim as long. So is it actually changing their will to live? I don't know. So what you do is you control or you keep constant as many variables as you possibly can for all groups. So in my Cheeto experiment, I might have a very specific diet they're on besides the Cheetos. I might ask them how many hours they slept to find a way to control for that. All kinds of things like that. And that is where the art form comes in, right, of the experimental design. Find those confounding variables, really think through what could possibly affect this outcome, and then try to find a way to keep that variable constant. All right, placebo effect. This is my favorite thing. I love this. So a placebo effect, if you remember, I told you in the control group, they get, like, let's say I'm doing an experiment on a new drug and it's an injection, okay? Let's say COVID. Let's do a COVID vaccine, for example, okay? So I have two groups. One group is getting the vaccine, the actual vaccine, so that's my experimental group. The other group is not, but they are getting an injection of saline. So they're still getting an injection. They think they got the vaccine. The placebo effect would basically be something that they think they got it. And so they would show symptoms. Like they might say, oh, I was so tired the next day and I felt like a fever. But why? I mean, that's crazy, right? Like they got saline. That's just salt water. It shouldn't have had any effect. But the brain is so powerful that it can actually create this placebo effect. It's so powerful that actually, I think back in the 60s or 70s, they used to sell a pill called Obicalp, which is actually placebo backwards. And it was just a sugar pill. And they would sell it at like Walgreens, and parents would use it on their little kids. I've done this. I know that sounds horrible, but like when my son couldn't sleep, I would give him a half a Tums and tell him to just leave it on his tongue and that it was a sleeping pill and that as it dissolves, he would fall asleep. And sure enough, within like 30 seconds, he would be asleep. So that placebo effect is very powerful. So here's an example. An antidepressant medication will treat depression. So basically, if you take something that isn't actually an antidepressant, but you think it is, you will actually feel better. Pretty crazy. I do have a video here. I'm not going to play it in the class or in this video, because you can watch it on your own if you want to learn more about the placebo effect. It goes all the way back to like really long ago. I think placebo is Latin for, I can't remember what it is, something like make you feel better or something. I don't know. It's in the video, so watch it. All right, now let's move on. Let's talk about being a critical reader of science. If you think about how many things could go wrong in an experiment, what you've just learned about, so confounding variables, placebo effects, the inability to control for human variation. Basically, experimental design is fraught with mistakes. And so when you're reading science and science literature, you absolutely have to be skeptical, okay? Be skeptical, be humble, and be curious. I remember this scientist I knew once that he always said, if I have a belief, I do everything in my research and everything in my power to deny that, like to find a way to disprove that belief. That's being skeptical, okay? Another example would be, I remember a study that was done, and the data showed that chewing gum increases test scores. And so for a while, like I was like, oh, this is awesome. Like I'll have all my students chew gum during tests. Well, guess who funded the study? Wrigley's, yes, a gum manufacturer. So there I'm being skeptical, like, really? Has it been reproduced? No, it has not. That was a single study. So I stopped giving gum to my students. So how does false news spread? Again, you can watch this video. I don't really want to spend the time in this video to watch it, but if you want to see how it spreads, it understand that like it's almost like a parasite, right? Like when people spread news, it's not meant to be false, but it grows kind of like a fungus. Okay, so how does it spread? We just went over that. I will show this video. This is just a short clip of a 20-minute John Oliver. He's funny if you've ever watched him. This one is student safe, so there's no swear words, but I think you'll get an idea of just how insane some studies are. So here we go. Oh, sorry, it went to a different thing. Hang on. Stop. Okay, I'll be right back. Okay, well, I'm gonna have to show you that at the end of the video, so bear with me on this one. But basically, he even has this graph. It's not in this clip, but he has this graph that shows curing cancer or causing cancer, and it's all the studies that have been done on certain foods, and all of them are both. So it's really hard to trust the science. You guys have heard it, right? Like, oh, butter's good for you, butter's bad for you. Salt is good for you, salt is bad for you. So it's really hard. I mean, with COVID, good Lord, we've had so many like, wear a mask, don't wear a mask, get the vaccine. Oh, now the vaccine doesn't protect you. So be really critical of any kind of statistics. That's all I'm going to say about that. Okay. This is a really cool video. Again, I'm not going to show it in this one, but these are all links that are in the slides, and the slides are on Canvas. So if you're interested, absolutely go in and watch it. In this case, there's an AI, artificial intelligence, that can actually take these clips and put a different speech or a different quote and make it look like that person is talking about it. It is insane. So if you watch this, you're going to be blown away, and you're not going to trust anything else you see ever, because it is crazy what they're able to do with computers. Okay, that's it for this video. Your homework is to watch this TED Talk with Ben Goldacre. He talks very quickly, so don't speed the video up because you won't understand it. There is a reflection on Canvas with these 3 questions. So what factors influence whether or not we listen to it? There's a lot of bias with that. How do we translate research from a lab to our lives, which teachers right now are kind of going through that. Like, how do we look at a neuroscientific research on cognition in a lab? Is it going to have the same effect in the classroom? And then finally, what are ways that researchers rig the data to make the point they want to make? So that's it. That's your homework. And kind of think about these things, these questions. It's not homework or anything. This is just what I want you to think about personally. Have a great day, guys. See ya.